Hey there, awesome physics students. Let's talk about free body diagrams. Free body diagrams are a critically important part of the problem-solving process in physics. The first question anyone will ask you if you are stuck on a problem is, what does the free body diagram look like? And if you haven't drawn the free body diagram, then you haven't really begun to solve the problem. They are a required part of problem solving. So let's go ahead and begin here. The idea with free body diagrams is very simple. You want to draw the forces acting on an object, and you want to draw forces that are acting on the object by an agent, an external agent. And what do I mean by external agent? Well, you recall that the forces require two objects, an agent which causes the force and an object that feels the force. So we only care about forces that are acting on the object. Let's begin with an example. Let's think about me. What are the forces acting on me right now? Well, when you're beginning, it's probably useful to draw a little picture here and even circle the object. That's the object you're thinking about. And we only care about the forces on that object. So while we're doing this, so I'm going to represent the free body diagram like this as a circle. We want to ask ourselves a list of questions to help us recall all of the forces that can be acting on an object. So one of the first questions we want to ask here is it touching anything else? And in this case, I'm touching the floor, so there's going to be a contact force, that normal force, that is perpendicular to the surface of contact acting on me. And of course it acts up because it's going to, the agent is the floor, and so that's going to point up and away from the floor. Another question you want to ask yourself is it on the earth? And this seems like a silly question, but of course we want to, what we're getting at here is, does gravity act? And yes, gravity acts because we're on the surface of the earth. So most of the time in our problems you're going to have that force. Another question you want to ask yourself is it sliding? And what do I mean? Why would I care about it sliding? Well, if it's sliding, then friction, either static friction, if it's about to slide, or kinetic friction, if it's actually sliding, will act. In this case, I'm not sliding, so there's no friction on me. Let's do a few more here. If it's traveling at high speed, then drag force may be important. In this case, I'm not traveling at high speed, so that doesn't apply. It could be, are there any springs attached? Well, there's no springs attached to me, so we don't have to worry about a spring force. And then finally, another one that's commonly encountered is, are there any ropes attached? In which case, tension would apply, ropes or chains. There's no ropes or chains attached to me, so there's no tension on me. So this is it. This is my free body diagram here. Let's do another example. Let's do an example of a skier skiing down a hill at an incline. So in this case, I'm just going to draw the skier as a box. So let's run through our list. Is the skier touching anything? Well, the object here in this case is the skier. So we only care about forces on the skier. In this case, the skier is touching the ground, so there's going to be a contact normal force perpendicular to the point of contact here. So this is where you need to remember some of the things you learned about forces. It's on the earth, so it feels gravity. Gravity acts straight down. It doesn't change directions, even if it's on an incline. Is it sliding? Well, we have presumed that the skier has some velocity this way, and so the frictional force will be opposing that, and that will be sliding friction. So you could draw that as kinetic friction. I've just called it friction in this case. Friction opposes the motion. Is it traveling at high speed? I think most skiers would avoid traveling at such high speeds that drag would be important, although some will. It depends on the details of the problem. For our purposes here, we'll say no, that the skier is not traveling at high speed. Are there any springs or ropes attached? No. So I think we're done here. We have these three forces. All right. Notice I drew the velocity off to the side. Sometimes you may even want to draw the acceleration off to the side. In fact, it's very useful to do when you're considering your coordinate system. But this leads us to another important point of what not to draw. So you don't want to draw certain things on your free body diagram. Here we're only drawing forces. Okay, so don't draw velocity on your free body diagram. I've drawn it off to the side, that's fine. Do not draw acceleration on the free body diagram. I've drawn it off to the side, that's fine. Another important thing is don't draw forces caused by the object that you're interested in. Okay, so the skier, for example, is going to put a force on the ground pushing the snow in. We don't care about what's happening to the snow. Our object is the skier. We only care about what's happening to the skier. We don't care about what the skier does to other things. Okay, let's do one more here. Let's say someone's descending with a parachute. And so there's a person, they have a little parachute here. Let me draw that a little bigger. Okay, and they're falling down at constant speed. So what are the forces acting on them? Well, again, I want to think about what is the object here. I think in this case, the object is the person and the parachute together as one unit. Okay, I only want to consider forces that are caused by something outside of the parachute. Okay, so let's go through our list. Is it touching anything? Well, no, it's not. It's just in midair, so there's no contact, no normal forces. Is it on the earth? Yes, so it's going to feel a gravitational force down. Is it sliding? No, there's no friction. Is it traveling at high speed? Well, in this case, the parachute is very large, and so drag is important in this case, and so there will be a large drag force that opposes the velocity, right? So we have to use our knowledge about drag. Are there any springs attached? No. Are there any ropes? Well, this is a little confusing. There are ropes inside here, but are there ropes from an external agent? No. These ropes are inside of the object. So we don't care about those forces. We only care about forces caused by an external agent. And these ropes are inside my object. They're not caused by an external agent. So we only have these two forces acting. Okay? Okay, hopefully this gives you an idea. I would highly recommend you keep your list of forces at hand when you're drawing these to make sure you don't forget any forces. And critically remember what not to draw on the free body diagram.